Good evening all. Welcome to this evening's webinar on further mathematics, time series data with our presenter, David.
Well, good evening everyone and welcome to the webinar. I think I'm talking mainly to Victorian teachers, but I'm aware that there might be some other people from other states as well, so welcome as well. Okay, my brief is time series, and I have a number of things to try to get through, and no idea whether I can get through all of them in the hour, but I'll just give you a summary of what I'm planning. I'm first going to start on ways of getting time series data from the internet to the calculator, and also looking at a couple of in fact one website that has some excellent time series data. Then we'll move on to a smoothing session, and then finally de-seasonalising. Now, if I have to speed up in order to get through everything, please accept my apologies. I've already sent to Brian the file, the calculator file, which has the things that I will be demonstrating tonight. So I believe Brian will be able to send that to you at some stage. Is that right, Brian?
That is correct. Following all webinars, we send out a link to the participants indicating where they can then download both a copy of the files that you've demonstrated plus a recording, an actual recording of the entire webinar. I know many teachers, myself included, view webinars and then say, hey, that would be great to show to my students, and so do that.
Okay, excellent. All right, let's get into it. So the first subtopic is getting time series data, and I think as teachers we're often looking for good, realistic time series that we can use to help students understand the link between those two variables in realistic contexts. And I was really lucky when I was preparing for this to find a site which some of you may already know, so I'll just type the way that I found it, which is to type in data market and Monash. And the reason for putting it in that way is because recently the data market stuff was sold off to corporate entity, but if you type in data market Monash in your Google search, it will come to this page, and the first link is a link to an excellent, really excellent website run by, up until recently at least, by Rob Heinzman, Professor of Stats at Monash University, Australia, who seems to have curated an enormous amount of useful time series for free use, basically. So I'm going to take the time to look at a couple of examples, the first of which I'll just do within the data market site, and the other one we'll try to get that into Excel and then into onto the calculator. So here we go. So the first example, you can see here on the left all the categories of time series that are available. The first one I'm going to select is crime. I hope you can see that on your screen. So if I click on crime, it tells me that there are 4 time series that you could look at, and the one I'm most interested in now is the deaths from homicides and suicides in Australia. So apologies for the morbid topic, but it was a good initial example for time series. Here we go. Into that.
It's all on screen, David, no problem.
Can everyone see that in the time series? Brian, you can see that as my spokesperson?
Yes, that's on my reflected screen. All good.
Okay. So it's not a very nice interface, but just using this first one as an example, it's the deaths from homicides and suicides in Australia, so deaths per 100,000 people, from 1915, I believe, to 2004, and it has homicide in blue and suicide in, well, looks like honey tan or something like that. So you can see in that time series, in the line graph that goes along with that time series, some drop-offs towards the end, but it does look as though the variation in suicide is greater than that in homicide. But of course, there's much more to the story than that. And this great site means that if you just wanted to choose to look at suicide, you could click that option off, and then it rescales the window if it needs to. So this one is just the suicide, and this is just the homicide. So you'll notice that it's done some rescaling, and it reveals some variation that may not have been present in the view that showed both homicide and suicide. So I'll now click over to non-firearm and homicide, and actually I'll change this to non-firearm and suicide. So as an example, this is quite a nice real data for showing some sort of cyclic pattern. Obviously, there may have been, and it allows you to select particular points. 1930 seems to have been a bad year, and times, I guess that's times around the Depression. I don't want to get into all the contributing factors that might be there. There seems to be another peak around 66, 67, and another one around 1998. But when we're trying to show kids or explain to kids what long-term cyclic patterns might be, it's nice to have some good examples of that. So that's just one example, and of course you can display and export this information as well. So I'm going to go back to the main menu and just choose, go back to this.
So we can get the raw data, can we, David?
Yes, I'm going to do that in a second example, sorry. Okay. So we're going to do something a little bit less morbid, which is monthly milk production in pounds per cow, 1962 to 1975.
I don't think the murder-suicide data is a bad thing to take a look at anyway.
No.
And I think, this is perhaps my personal view, but I think particularly suicide with our youth, I think it's a topic that should be discussed.
Absolutely.
We may have a mix of views from our listeners, but I certainly think so.
Yeah, and I didn't highlight this, but if you're mucking around with that time series on homicide and suicide, where you could separate them from gun-related and non-gun-related, you'll notice the interesting thing that happened after Port Arthur and the buyback of guns.
Yes.
There. So they're all really good things to show kids as the usefulness of time series analysis and just
absolutely, yeah, certainly agree.
So let's move to monthly milk production, and so as Brian said, there's not much dairy production up in your areas there, Brian. A little bit hot.
Well, there has been. You may have heard of the Kiwa Dairy, and the takeover there. Murray Goulburn has featured in the news a fair bit just last year. So unfortunately, our dairy is being closed. Our local dairy processing plant has been closed. Sensitive issue, David.
Yes. We don't know which things are sensitive, do we? So let's have a little look at this. So if you move away from the Select tab to the Display tab, you'll notice here you have an option to choose a subset of the data. So in the time period here, I'm going to change this from I'm going to go from January 1962 to December 1971, and my logic is that I want to get 10 years of data. So it automatically updates the time series, sorry, the line graph. And it also here, interestingly, allows you to change the running average to do a little bit of smoothing that way. You can see that there's a very clear seasonal related pattern in the data, and also an apparent increasing trend. So just another example of some data that might be useful to show the kids that is realistic examples of particular aspects of time series. Okay, and just while we're here, before we leave it, if I change this to a running average of 12, you'll notice that it allows you to see the underlying trend a little bit clearer. Let me just change back now to 1. Okay, so we're going to export that. So that's the last option here. And obviously this is so much more sophisticated for export of data than most sites that you might be getting data from, but I think it's a great starting point. So we're just going to make a spreadsheet and to export it, and it'll only export the stuff that we did from the start of 62 to the end of 71. Download data, and that'll make an Excel file. Okay, so let me just open Excel. Okay, and if I just change back to the web browser and show this.
So we get the numerical figures here.
Yeah, you get the actual data. I'll open it with the Excel version I've got. And hopefully you can see that. I'll make it a little bit bigger if I can.
Very useful. Yep. I think a lot of teachers I've found aren't aware that the Excel spreadsheet and the lists and spreadsheets in TI-Nspire are pretty much compatible. I think that's what you're going to show us, aren't you?
Yeah. So that might be a better view to look at it. And it comes in a very polished form. It tells you where it came from and the date that we got it, a link to the original file, and if there's any licensing information about it. It also sometimes on the website, I didn't really show this, but on the website it sometimes shows you more detailed information about the source. I did look at this one and find that it had a reference, but it didn't actually say exactly where it's come from. But we're going to ignore that bit for the moment. So you'll notice that in this case, when it's exported the data, it's actually got date information. Excel has, I don't know if you can see this up the top here in the bar, it says the 1st of the 1st, 1962, and it's been pre-formatted to show 1962 first month, 1962 second month. So we're really interested in the 122 values of the time series, but not as interested in this particular information here. So what we're going to do is just grab this and confirm, as you do in Excel, that it makes 120 values. And usually in Excel you can see there it's a bit small, but it says 120 by rows by one column. And if I just copy in the normal way, now I'm going to do some magic and go to the Nspire and make a new document and add a list and spreadsheet. So I've copied and pasted this, so I should be able to just paste, and you'll see that the data's come there. So rather than worry about which month in 1962, I'm just going to simplify this a little bit and call this milk. And you'll notice I don't have data here for the time, so I'm just going to put it in general time, and I'm going to put a sequence in here. So I'll just do this a bit slowly in case you haven't seen it. I want a sequence. So for those that aren't aware, with the spreadsheet, in that column underneath the labels, underneath the first row, that is in the second row, you'll see that you can put in formulas. And so if I type, as I did, equals, bring up a formula which I can put in to generate, really wanting to generate the time periods from 1 to 120. So that's my purpose. So I'll just call this a variable, and to make sure that I don't confuse it with column X, I'm going to put a little dash, which is, I suppose, like a single quote. And the first argument it wants is the expression, and it's all pretty irrelevant in this case, but I'm just going to do dash X, comma, and it wants to know what the variable is, dash X. And I want to go from 1 to 120, and I want to go in steps of 1.
So the X is so that we're not confusing it with the X of the spreadsheet column.
Yes, I could have made any. So if you can see after you've entered it in, it's got that little single quote before, and it just stops that problem that you have where it says, hey, do you mean the column variable X in the spreadsheet or another user-defined variable? So this
yes,
is sort of
so it's an important point. Yep.
Okay, so we've got that far, and now what we can do with, you can either go back to the home screen and create a data and statistics graph window, or if you just do Control-I or Command-I, it is for me on this Mac, and I'm going to add a data and statistics page, and you'll see this totally random looking display of dots, and that's the calculator software's way of saying there's no structure that's been imposed on this data, so tell me what you want to do. So we want the time here, and then you can tab across to there or click if depending on how you're doing it, and we'll have the milk production here, and you'll see the pattern. The next thing that you need to do is to join the data points because it's a line plot. And I found the easiest way to do this is just to press Control and then Menu, and we'll give you this option of Connect Data Points. You can get it in the menu systems as well. Okay, so that's as far as we've got so far. And just to show that you could look at the trend, we'll just overlay a regression there as well. So most people know all of this. So menu, analyze, regression, A plus BX. I'll just move that so it's a little bit more visible. And that may be useful. And we might also look at whether we can predict something that extrapolates well beyond the 10 years. So this isn't something I would recommend, but just for the sake of simplicity, the data that we've got here shows a pretty consistent seasonal pattern and an increasing trend. And if this trend were to continue, just basing it on that line of best fit, what would it be in another 10 years from then? So I guess that means at a time value of 240 rather than 120. So I'm going to insert now just a calculator page to look at, see how we might do that. So of course you could just write that down and then type in 240, but I wanted to show another feature which is not just about time series but to do with bivariate numerical analysis. So I'm going to insert a calculator page, and when I discovered this recently, maybe last year, I thought it was pretty cool. So if you, on a calculator page, and you press STAT and then the decimal point, it then pops up all of the statistical variables most of which have been generated by the regression analysis that we did. So if I do stat A, that's telling me the y-intercept of the regression equation that was fitted to the data. Stat A plus, and then do it again, stat dot, and then choose B, and multiply that by 240 to tell me what the predicted value that the regression equation would give after 20 years of data. And there it is. So that's just a fairly basic analysis of a time series and getting it onto the from the website to the spreadsheet to the calculator, and then some simple analysis that you might be able to do. Now, what I've skipped over is how to get it to the students. And for that, I'll see if I can do this really cleverly. I'll just tell you what my experience is. And I think I've got it in this folder. I am a great lover of this device. So it's called the docking station. I checked today, it does cost $200, or sometimes people get it, schools can get it in their volume purchase, but I found it exceedingly useful for updating operating systems and for sending files to my class. My Year 12 further class is nearly 20, I think it's 23 students. So having a quick way to send things, this seems to be the simplest option. And while I'm talking about my own experience, I'll just close this down now and go back. Yeah,
unless of course you've got Navigator. But
if you have a Navigator-based system, then you would be able to do it that way as well. In my school, in my general classroom, I don't have that, so this is my best option.
Yeah, but likewise, at the school I was at, we also got those docking stations and the yellow Wi-Fi caps through the volume purchase program, which is a good way to go.
Absolutely. Okay, so the thing that seems to be not well known is that there's a really nice way of sending things. If you look at the standard view in the teacher software, or if you have the Navigator teacher software, we're in the Documents tab of the Nspire software. If you go to the Content tab, if you have the doc populated with calculators and the cable joined, the calculators will show up down here. And the best tool I've found is this transfer tool. So the transfer tool is a general way of getting operating systems or files and have them directly sent to all the calculators. And it's better than that. You can add your file, so for example the data file if you wanted to, or an operating system, you can add it to this. And then when you're ready, you press Start Transfer, and any of the calculators that are connected will have those files transferred, or if it's an operating system, it will actually transfer and update the operating system. The other thing about the doc is that when you, if you take the calculators out once they're finished, having the transfer completed, and you put more calculators in, it just automatically detects that a new calculator is there and transfers the files to it as well. So I guess I'm saying I'm a big rat for that way of doing it. But as Brian said, if you do have a Navigator-based system, the same tool will work, the transfer tool. Okay, so I didn't want to sort of just go past this data transfer thing without trying to explain a little bit about that. So I think we might move on to smoothing, considering we're already half an hour in. Okay. We're going to move on to a thing called smoothing of time series. So I'm going to transfer to another document, and I'll just remind you that I said that I've already sent Brian this file, and so if you're interested in this file, then Brian will be able to get it to you somehow, I believe. Okay, so we're going to start with smoothing, and just smoothing at a given time value. And the reason for doing this is it's a common exam question. I think that's been the compromise. Obviously, you can't get students doing lots of smoothing calculations in an exam, but just having a single one for a time series, such as what's the centered 4-point moving mean for this time series centered on a particular time period, like the 6th time period. So I'm going to show this method of doing it via the notes page, and I have already created this page, but just in case you were wanting to do this, if you press home, you'll notice that the notes page is here, so I can add another page, and that'll be a notes page as well. It doesn't look like it's a notes page particularly, it just looks blank at the moment, but just to show that you can do that. I did an undo, which a lot of people, I think, not sure about, but because of the multiple undos, I can undo adding or inserting a new page. And while we're at it, just very quickly, if I did that again, a lot of people find if they create extra pages, they'd like a quick way of getting rid of them. And I believe if you press Dock, the Dock key, page layout and delete page, that gets rid of that as well. Go back to 1.1. Okay, so here's a time series. It's only got the Y values of the time series, or the actual values. The time values aren't here. But we're going to use this as an example to lead into a template that you or your students could generate to help answer these sorts of exam-style questions. So smoothing at a given t value. So we've got some values here which I'm going to use, but you'll notice here that this is just text, like I was just recording notes or some information that might be relevant. However, the notes page allows you to do maths as well, and that's what we're most interested in here. So in the menu, you'll notice that it's a menu, as usual, that's particular to the notes application. And what we want to do, without getting too bogged down in the detail here, is we want to insert a maths box. And you'll notice it says Command M, or if you're on a PC or on the calculator itself, I think it's Control M. And it generates a maths box, which you'll see with the red ants around the outside of some black ants. And that's just indicating that it's a live maths box. The first thing I want to do is define the time series values, the Y values. So I think I'll just call this YVal. And on your calculator, if you want to store something as the YVal variable, Control, and then the template key, you'll see it says : equals. So it means assign to Y value the following things. Then you need to give it a set, the set brackets, which you'll see on the keyboard on the left is highlighted. And I'm just going to go up to here and select this data. If you're doing it on the calculator, you can do the same thing I just did then by doing Shift and then the arrow. I'll copy that in there. And the maths box thing that you entered in the maths box isn't treated mathematically until you press the Enter key. So if you do that, you'll see that it's created. It's basically giving an output to say, yep, okay. So if I type YVal, it would now contain that list. And I'm also going to do a particular t value. And so let's say I'm interested in just a 3-point moving median centered on the 6th time period. So I'll get rid of this t-val here and insert another math box, so Control M or Command M, and the particular t-val that I want to assign is 6, because I'm interested in the 6th time period. I move to the next line, and now what I'm going to try to do is generate that smooth 3-point moving median based on the time value of 6. Okay, so I'll call it med3 colon, oops, I need to make a math box first, my mistake. Med3 colon equal. Now, what I need to do is get the median of the 3 values that are around the 6 diameters. So 1, 2, 3, 4, 5, 6. I want it to find the median of those. I want it to be clever enough so that if I change the t-val to another time period, it will also calculate it. So let's see how we go. So I want the median of a set of numbers. And the set, so I'll do, oh, what have I forgotten to do again? I'll jump out of my box. MED, 3 equals median, open bracket, set bracket. Now I want y-val, and I want the one just to the left of the 6th value, and the 6th value, and the one to the right. So y-val, and if you're referencing a particular value inside a list or a matrix, you've got to use the square brackets. So I want y-val of the given t-value minus 1. So I think that's... Oh, can you still hear me?
Yep, we're all there.
Okay, comma, y-val. Can you hear...
I'll get you. Someone's phoning in the background, I think.
They're calling me.
Yeah.
I think everyone agrees I can call him back.
Yes.
And the third one is y-val. t-val plus 1. And I believe that will give me the answer. So now that that's set up, if I change the t-val to 5, you can see that it will automatically update the 3-point moving median. Now that all looks a bit ugly there, but that's one of the nice things about the notes page, that every math box can be have its display and its format modified. So if you click on the math box and then do Control Menu, or I'll go to the menu to show you, math box options, math box attributes, you can say that I would rather not see the input, just the result. You can also, while we're here, change the display digits as well if you want to change the display position for that particular box. So,
and I know you've set these things up, which makes it much more student-friendly, shall we say.
Yeah.
So
you'll see here what that's done is it's still generating the values. So I'll just put another value in, 8. And it is calculating, but it's not telling you much. And this is a good point now to illustrate with these math boxes. You can do the following, the 3-point moving median at t equals, and then I can put a math box here, I'll just do it quickly, at t equals, and I'll put t-val, is, oops, jump out of this, indicate, but I might choose change the attributes of that. It doesn't show the input.
So I hide that.
So there you have a sentence which is telling you what that 3-point moving median is at that time value.
Mm-hmm.
Now, because of time, obviously we can't do much more than that. But here's something I prepared earlier. 1.2.
And something that, of course, students can take with them into their exams or have with them as they work through their things. I know, David, I've pinched some of your stuff in the past and used it as widgets, single page.
Another example of that. So this is sort of a completed version of that. And you'll notice there that it looks similar to the previous page, except it's doing a couple of other things. It's doing the 3-point and 5-point median smoothing, the 4-point centered one, and then the similar ones for the mean. It's also telling you how many data values there are, and that formula there is just dim. So the dimension of the list Y is 11. Notice when you click in it, you see the input and output, but I've formatted that one so it only shows the output. And so you'll just show the case. That's pretty much what we did before.
Yep, but at the moment it's only working for those values that you've got in your Y list, though, isn't it?
That is, but I think what Brian's trying to allude to is you could just change the data. Thank you, Brian. You could just enter extra data or less data or change the values, and it would automatically update that as well. I'll just spend 30 seconds maybe looking at a more complicated version. The 4-point centered median or mean method, I think people know the lining up issue and then doing a second step to find the one that's centered on a particular time, such as T-Nspire, for example. And it makes the formula a bit uglier, but I'll just show what it is. You're essentially finding the median of two medians. And this is like showing that nesting that's there. It's a little bit painful to type in. Once it's there, it just works, but I thought it's just worth showing that one. All right, it's 7:46, so let's move on to another smoothing-related thing, and this is a good opportunity to mention, which I will now, that TI has supported the production of quite a lot of student and teacher activities for the VCE course and for other courses around the country. And the procedures that I'm about to talk about in relation to making a smoothing template, not the notes page, this is a new thing we're about to do. All the instructions are here for students or for teachers to do. So this is the teacher version of what a smoothie, and it's really about creating this template. So you can see where it's going, multiple pages. Some of the formulas are a little bit detailed, but because of that, we've got some instructions here about how to construct it for students and for teachers. So I just wanted to show that briefly and put a plug-in for those activities.
Yep.
That are on the TCube website, Brian.
I'm just typing the link in now.
Oh, I love your work. All right. So we won't have time to do this in detail, but you'll notice that unlike the previous notes page, this is a spreadsheet page, and it's already been set up. So it's not too surprising that the first two columns in this spreadsheet are the time values and then the Y values. And this formula in the third column is for the 3-point moving mean. So I'll just click in a cell here. You notice it's got a little dash there because we know that you won't have one centered on the first time period for that smoothing method. And if you go to the next one, you'll see a pretty ugly looking formula. It's a bit harder to see there, but if I click on it, and if you look down the bottom of your screen, it's got an if function. And what the if function is doing is saying, do the 3-point mean, that is, find the average of the mean of 13, 15, and 11, provided, and do it up until the row before the last row. So that'll make more sense here. So, and if it is beyond that, just put in nothing, which is what that is there. Put in space, leave it blank. I'll just jump out of that and go down to this. It has 11, it's the same data values as before, and you'll notice that the formula's still here. However, it's not before the second, or including the second last line, according to the time values that have been entered, and so it's going to put in a blank. So that little trick means that you can get it to put in the correct values if they're relevant, and that's really part of that. I might just change the document view to computer so that it's a bit easier to look at. So, can you see that screen? Are they a bit small, or are they okay to look at?
Yeah, the sizing is good. Yep.
All right, so I just mentioned briefly that you've got the 3-point mean, 5-point mean, 3-point median, 5-point median, and there's something a little bit dodgy happening with the 4s. And the reason is because they're really not lined up correctly. The interesting thing, or the thing that you're most interested in, is this centered one. And the formulas that are there for that look a little bit ugly, but they allow you to line it up on the correct time periods. So this is quite a useful spreadsheet template, and allows the students to focus on creating the smooth time series and looking at it in terms of its values and also in terms of the graphs. So here's the original time series as a line graph. And if you recall, over in YVal, you can, with the menu, I believe you can add a Y variable, but I don't know about you, but I found that control menu is the best way to do this because it's sensitive to the context that you're clicking.
Yes.
And add the Y variable, and all of the smooth values are there. So I'm going to add just the mean 3, and you can do the same thing again, add another one for mean 5. So that tells you, if you look at the green, that the smoothing is more extreme, and there's good discussion points with students about what sort of smoothing period is appropriate or is most helpful. You're on a calculator screen, so there's a limited sort of number of pixels, and you can see it already starts to look a bit ugly if you have 3 line plots. But on the computer view on the software, it's a little bit nicer to look at. So it's worth, if you're using the overhead version on a whiteboard or a data projector, you've always got this extra resolution to work with if you're demonstrating some of these ideas. So that's all I really wanted to do about the smoothing, and I'd like to finish in the 8 minutes that remain with some stuff to do with time series. To do with de-seasonalising.
Yeah, yep.
So this is a spreadsheet approach. So the main business in the Further Maths course is to create use some time series data, hopefully over more than 1 year, to generate seasonal indices, and then to use that to remove the effects of seasonalisation, fit a regression line to the de-seasonalised time series, and then to re-seasonalise to see what the predicted values will be. So that's a very crude summary of what's expected for further maths. And I thought I'd try two approaches, one of which I hated and one of which I loved. So the spreadsheet's the one that I hated. But just to show the method, you can see that there's an issue with spreadsheets on the calculator, that you really only got 6 columns, depending on how wide your columns are, to work with, and only 5 rows. So even though it is a true spreadsheet in that sense, that you can have column-wise, row-wise or cell-wise formulas, it's a bit clunky for viewing, and I couldn't work out how to make the font a bit smaller on the spreadsheet. So I'm going to resort to my computer view to illustrate how it works. So this is our standard quarterly data for year 1, year 2 and year 3, and yes, you can put in a formula. I don't know if you can see, can you see that formula down the bottom of the page, Brian?
Yes, yep, the mean, yep, of B2 divided by the mean of,
Yep. And you'll notice that I've used some absolute cell reference stuff with the dollars.
Yes.
I don't think I will go into that now, but that allows you to copy and fill down formulas and fill right if you need to, with not much work. So you can find the seasonal indices for year 1, 2 and 3, and then in that row 8 you can see there's right? Yeah. Okay, so calculating the overall seasonal index. And then you can find the actual values. Jump out of that column, which I think is the problem. That's wanted. That's the overall seasonal index, which is just a mean of those 3 for that quarter across the 3 years. This data down here is the de-seasonalised data. And this rather clunky thing here is just grabbing the values from here. So this is equal to B10. It's just moving it across and allowing you to create the time series. You need to get out of this 3-row by 4-column format if you want to do a regression. It's quite painful to do it when the data's like that. So I've turned it into this column variable, which allows you to do a linear regression, which has just been applied here. And then you can use predictions here. And there's a formula here called mod, which I think needs to be modified as well. That's not a pun. There's a way to do it. But if you look at this formula, you'll see that it's pretty ugly. And what it's really trying to do is get the predicted value for time period 17. It's correctly calculated that it's in the first quarter, and it's re-seasonalising it. So the template works, I believe, but it's not my preferred option. But it's worth seeing that so you can see how cool the next one is. So this is a notes page approach. So in the 3 minutes that remains, so what it's doing is the data is still presented in the quarterly format, year 1, year 2, year 3, and then the seasonal indices are calculated by, I'll just show this one as an example. The year 1 seasonal index is just the year 1 values divided by the mean of the year 1 values. And similarly for the other 2. And then the seasonal index is just the 3 seasonal indexes added up and divided by 3. That's not rocket surgery. And you still have this problem with the data not being in a suitable format for a single column for doing regression. However, there's a command here. So this list here is the de-seasonalised values. But what you really need to do is stitch together the de-seasonalised year 1, year 2 and year 3 data. And there's a command on the calculator called augment. So this is really just for the nature of this command. What you're doing is just getting the year 1 data divided by the seasonal index and the year 2 divided by the seasonal index and stitching them together. And then you're doing another augment which stitches together the third one. I think that works fine. But it's not a pretty ugly looking formula. And then you can do a regression. And this is a regression on the fly. So what it's doing is it's saying, I want a linear regression of the form A plus BX, where this value here, where the time values will just be generated. I've used X here, but I'm not sure why. But anyway, it just generates the 12 time period values as the explanatory variable, and then uses the seasonalised data for Y as the response variable. And then it outputs the statistical parameters A and B, and we have the rule. And then I believe let's do the last part of this. That's the seasonalised Y value equation, and then it allows you to put in a predicted value using similar formulas to the previous page, the seasonalised value, and then a re-seasonalised value based on the correct quarterly index. So I'm sorry that that was a bit rushed at the end, but I think hopefully there's been enough examples for you to see some of the tools and the aspects of the calculator that can be used to help with the learning of time series, but also exam performance. Over to you.
Very good. And, yep, thank you, David.